National Electrical Code Article 700 addresses emergency systems. Section 700.12b3 specifically covers overhead wiring. It states that emergency circuits may be run overhead outside of buildings where the wiring is supported on poles or other approved structures and is not subject to physical damage. Section 700.12b4 addresses underground wiring. It states that emergency circuits may be run underground in raceways where the raceways are protected against physical damage by being laid in concrete, embedded in earth, or in underground raceways protected against mechanical injury. Article 338 focuses on service entrance conductors. Section 338.10b addresses where underground installations are required. It states that service entrance conductors shall be installed underground where required by the authority having jurisdiction. Other considerations include local building codes. These codes may have additional requirements for the installation of standby power cables. It is important to consult with local authorities to ensure compliance with all applicable regulations. Running a standby power cable overhead via mast or service head is not prohibited by the National Electrical Code and is an acceptable method provided it meets the requirements of Article 700.12b3. The cable should be adequately supported and protected from physical damage. Underground installation is generally preferred where it is required by the authority having jurisdiction or where it is necessary to avoid physical damage. In situations where underground installation is difficult or expensive, running the cable overhead can be a reasonable alternative provided it adheres to the code requirements for support and protection. To summarize, running the standby power cable from the generator through the garage roof via mast or service head is not prohibited by code. This method is acceptable if the cable is properly supported and protected from physical damage and complies with all local building codes and regulations. Firstly, consider the National Electrical Code requirements for emergency systems. Article 700 provides guidelines for the installation and wiring of emergency systems, including generators. Secondly, review Section 700.12b3, which specifically addresses overhead wiring. It permits running emergency circuits overhead if the wiring is adequately supported and protected from physical damage. Thirdly, consider Section 700.12b4, which covers underground wiring. This section allows underground installation in raceways that are protected against physical damage. Fourthly, reference Article 338, which deals with service entrance conductors. Section 338.10b stipulates that service entrance conductors must be installed underground if required by the local authority having jurisdiction. Fifthly, investigate local building codes which may impose additional requirements or restrictions on the installation of standby power cables. Sixthly, assess the physical conditions and potential for damage to the cable. Overhead wiring must be protected from physical damage, while underground wiring must be protected from mechanical injury. Seventhly, evaluate the cost and feasibility of each installation method. Underground installation may involve tricky horizontal boring or disrupting sidewalks and flower beds, which can be expensive. Eighthly, ensure that the cable is properly supported and secured. Overhead cables should be supported by poles or other approved structures. Ninthly, verify that all electrical work is performed by a qualified electrician who is familiar with the National Electrical Code and local building codes. Tenthly, obtain any necessary permits and inspections from local authorities before starting the project. The authority having jurisdiction has the final say on whether the service entrance conductors should be installed underground. Running cables underground typically involves using a raceway for physical protection. This raceway can be directly buried, encased in concrete, or installed within an underground duct bank. The type of raceway used should be appropriate for the specific application and environmental conditions. Common types of raceways include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and rigid polyvinyl chloride conduit. When running cables overhead, it is essential to maintain proper clearance from the ground, buildings, and other structures. The National Electrical Code specifies minimum clearance requirements for overhead conductors depending on the voltage and location. The cables must also be adequately supported and secured to prevent sagging or movement. When transitioning from overhead to underground, it is necessary to use appropriate fittings and enclosures to protect the cables from moisture and physical damage. The transition point should be located in a weatherproof enclosure to prevent water from entering the raceway. The type of cable used for the generator connection should be suitable for the intended application and environmental conditions. Common types of cables include THWN, THHN, and XHHW. The cable must be sized appropriately to carry the required load, taking into account voltage drop and ampacity directing factors. The transfer switch should be installed in a location that is readily accessible and protected from physical damage. The transfer switch should be properly grounded and bonded to the electrical system. The generator should be equipped with a disconnecting means that is readily accessible and located near the generator. The disconnecting means should be capable of interrupting the full load current of the generator. The generator should be properly grounded and bonded to the electrical system. The grounding electrode conductor should be sized in accordance with the National Electrical Code. The generator should be installed in a location that is well ventilated and protected from the elements. The generator should be operated in accordance with the manufacturer's instructions. Regular maintenance should be performed on the generator to ensure that it is in good working condition. The installation of a generator and transfer switch should be performed by a qualified electrician who is familiar with the National Electrical Code and local building codes. The electrical inspector will verify that the installation complies with all applicable codes and regulations. Failure to comply with the National Electrical Code and local building codes can result in fines, penalties, and even legal action. In addition, an improper installation can create a safety hazard for people and property. Therefore, it is essential to ensure that all electrical work is performed by a qualified electrician who is familiar with the applicable codes and regulations. Article 700 of the National Electrical Code provides comprehensive guidelines for emergency systems, covering various aspects such as power sources, transfer equipment, wiring methods, and lighting. The article aims to ensure that emergency systems are reliable and capable of providing power during power outages or other emergencies. Section 700.12 specifically addresses power sources for emergency systems. It allows for the use of generators, storage batteries, or other independent power sources, provided that they meet certain requirements. The power source must be capable of supplying power to the emergency loads for a specified duration, typically 90 minutes or more. The power source must also be reliable and capable of starting and running automatically in the event of a power outage. Section 700.12b3 provides specific guidelines for overhead wiring for emergency circuits. It permits running emergency circuits overhead outside of buildings, provided that the wiring is supported on poles or other approved structures and is not subject to physical damage. The wiring must also comply with other applicable requirements of the National Electrical Code, such as clearance from the ground and other structures. Section 700.12b4 provides specific guidelines for underground wiring for emergency circuits. It permits running emergency circuits underground in raceways that are protected against physical damage. The raceways must be laid in concrete, embedded in earth, or installed in underground raceways that are protected against mechanical injury. The raceways must also comply with other applicable requirements of the National Electrical Code, such as grounding and bonding. Article 338 of the National Electrical Code addresses service entrance conductors, which are the conductors that connect the utilities service drop or lateral to the building service equipment. The article provides requirements for the size, type, and installation of service entrance conductors. Section 338.10b specifically addresses where service entrance conductors must be installed underground. It states that service entrance conductors must be installed underground where required by the authority having jurisdiction. The authority having jurisdiction is the local electrical inspector or other regulatory agency that enforces the National Electrical Code. The authority having jurisdiction may require underground installation for various reasons such as aesthetics, safety, or environmental concerns. When running service entrance conductors underground, it is essential to comply with all applicable requirements of the National Electrical Code and local building codes. The conductors must be installed in a raceway that is protected against physical damage, and the raceway must be properly grounded and bonded. The conductors must also be sized appropriately to carry the required load, taking into account voltage drop and ampacity directing factors. Local building codes may have additional requirements for the installation of standby power cables, such as specific requirements for the type of cable, the size of the cable, the method of installation, and the location of the cable. It is important to consult with local authorities to ensure compliance with all applicable regulations before starting the project. Failure to comply with local building codes can result in fines, penalties, and even legal action. Therefore, it is essential to ensure that all electrical work is performed by a qualified electrician who is familiar with the applicable codes and regulations. A qualified electrician will be able to assess the specific conditions of the project and determine the best method of installation to ensure compliance with all applicable codes and regulations. A qualified electrician will also be able to perform the electrical work safely and efficiently, minimizing the risk of injury or property damage. In addition to complying with the National Electrical Code and local building codes, it is also important to follow the manufacturer's instructions for the installation and operation of the generator and transfer switch. The manufacturer's instructions will provide specific guidance on the proper installation and operation of the equipment, ensuring that it is installed and operated safely and efficiently. It is also important to maintain the generator and transfer switch regularly to ensure that they are in good working condition. Regular maintenance should include checking the oil level, cleaning the air filter, and inspecting the wiring and connections. The generator should also be started and run periodically to ensure that it is functioning properly. By following these guidelines, you can ensure that the installation of a generator and transfer switch is safe, efficient, and compliant with all applicable codes and regulations. This will provide reliable backup power for your home or business in the event of a power outage.